Good morning, children. Today's topic is dependence of EMF on concentration of electrolyte and temperature, and it is nothing but Nernst equation. This is a very important topic. Already in previous class we have discussed about the standard electrode potential. In that case, the concentration of electrolyte was 1 molar and temperature was 298 Kelvin. But here, in this topic, we are going to focus what will happen to electrode potential if concentration of electrolyte is changed or temperature is changed. Suppose one is asking what is Nernst equation. Your answer will be the equation which provide the relation between EMF and concentration of electrolyte and temperature is known as Nernst equation. So I am going to derive it. Please look. For general reduction reaction Mn plus aqueous plus n electron gives M salt. Then Mn plus aqueous divided M solid is equal to E naught Mn plus aqueous M solid minus RT by NF ln QC. Here QC is reaction quotient. ln means logarithm based E, or E Mn plus aqueous M solid is equal to E naught Mn plus aqueous M solid minus 2.303 RT divided NF log QC. QC means the product divided reactant. Concentration of M solid divided concentration of Mn plus aqueous. By convention, we know that the concentration of solid is taken as 1. So, we can write this Mn plus aqueous M solid equals to E naught Mn plus aqueous M solid minus 2.303 RT by NF log 1 by Mn plus aqueous. Here Mn plus aqueous slash M solid is electrode potential. You can note down Mn plus aqueous slash M solid is equal to electrode potential. E naught Mn plus aqueous slash M solid is standard reduction electrode potential. Here R is gas universal gas constant 8.314 joule per Kelvin per mole. T is temperature in Kelvin. N is equal to number of mole of electrons gained during the reaction. F is equal to Faraday. So F is equal to, you can write F is equal to this is the charge of 1 mole of electron. So this is this value. So at 298 Kelvin E m n plus aqueous plus m solid is equal to E naught m n plus aqueous plus m solid minus 0.0591 by n log 1 divided by this. So this is the formula on the basis of which you can calculate electrode potential at any concentration of electrolyte. And here the temperature, this is room temperature only, 298 Kelvin. If temperature is given, then you have to use this formula, above formula. If temperature is not given, means it is assumed that it is at a room temperature. By calculation of electrode potential of anode and cathode, you can calculate electrode and EMF of the cell. So EMF of the cell is equal to E cathode minus E anode. We can write the general formula if the cell reaction, overall cell reaction has been given. Watch it, mind it. This is the formula for calculation of electrode potential of a single electrode. And if the general cell reaction has been given, then you should use the formula like this. Let the general cell reaction is AA plus BB gives CC plus DD according to Nernst equation. E cell equal to E naught cell minus 2.303 RT divided NF log QC. QC means concentration of this into concentration of this. So look it, C power C, D power D divided A power A and B power B. B power B. Now, at 298 Kelvin, at 298 Kelvin, E cell is equal to E naught cell minus 0.0591 by N log C power C, D power D divided A power A, B power B. In some books, here plus sign has been given. Under that condition, this denominator should be converted to numerator and numerator should be converted to denominator. So for avoiding confusion, always remember this equation only for solving your numericals. Before discussion of the numericals based on this Nernst equation, I want to explain the next topic, and the topic is, students please note all the things. The topic is equilibrium constant. Equilibrium constant from Nernst equation. from Nernst equation. This is again very important topic. So, already we have studied in electrochemical cell. What happens in electrochemical cell? Let the cell reaction is AA plus BB gives CC plus DD. With passage of time, concentration of electrolyte of anode half cell increases and that of cathode half cell decreases. It means E anode increases and E cathode decreases. Naturally, we have read on the basis of Nernst equation, as concentration of electrolyte increases, electrode potential increases. As concentration of electrolyte decreases, electrode potential decreases. So naturally, with passage of time, what happens? Electrode potential of anode increases and electrode potential of cathode decreases. A situation comes when E anode become equal to E cathode and E cell is equal to E cathode minus E anode become 0. Now E cell becomes 0. At this condition, equilibrium exists in the cell reaction. Now see, already we have read according to Nernst equation. So according to Nernst equation, E cell equals to E naught cell minus 2.303 RT divided NF log C power C T power D divided A power A and B power B. Question star. So at equilibrium, E cell is equal to 0, C power C, D power D divided A power A, B power B is equal to Kc. This Kc is equilibrium constant. Now, therefore, 0 is equal to E naught cell minus 2.303 RT by NF log Kc. This is therefore E naught cell is equal to what? It comes in this side. It will come 2.303 RT divided NF log Kc. So this is equation double star you can write. So at 298 Kelvin during solving numerical, this formula should not use for solving numerical. So numerical is only at 298 Kelvin. At 298 Kelvin, putting all these constant value are 298 F value, we get E naught cell is equal to 0.0591 by N log Kc. This is important formula on the basis of which you have to solve many numericals. Now the next content is Gibbs free energy. Next topic is Gibbs free energy. Gibbs free energy delta G. In class 11 already we have read what is Gibbs free energy. Already I have explained in class 11 that the decrease in energy which is used for non-expansion work like electrical work is known as Gibbs free energy. Again you listen, the decrease in energy which is used for non-expansion work like electrical work is known as Gibbs free energy, and in standard state it is known as standard Gibbs free energy charge. Therefore mathematically delta G is equal to minus W electrical minus W electrical. So electrical work done is equal to what? Charge. Electrical work is equal to, you see, delta G is equal to minus NF E cell. This electrical work is equal to Coulomb into volt. N is equal to number of mole of electron transport during the cell reaction. F is Faraday 96500 Coulomb. E cell electro EMF of the cell. So this is one equation. Standard gives similarly delta G naught is equal to minus NF E naught cell. This is standard free energy chain. Delta G naught is equal to standard free energy chain. This is the next formula. Now this is equation number, triple star you can write. Now the next topic is relation between delta G naught and Kc. Put the value of E naught cell from equation star in equation double star in equation triple star. We get what we get. See, delta G naught is equal to minus NF into 2.303 RT by NF log Kc. Therefore, delta G naught is equal to what? Delta G naught is equal to this NF will be cancelled out, minus 2.303 RT log Kc. Now, we got three formula here. Apart from Nernst equation, we got the formula of E0 cell and Kc relation. E0 cell is equal to minus 0.0591 by n log Kc. This is the formula if in your numerical E0 cell has been given. Then you have to calculate equilibrium constant on the basis of this formula only. And if in the question delta G naught has been given only, then you have to calculate the value of Kc on the basis of this formula. Delta G naught is equal to minus delta G naught is equal to minus 2.303 RT log Kc. Here R is equal to 8.314 joule per Kelvin per mole. T temperature in Kelvin. Now, on the basis of this formula, you have to solve many numericals, and for your assignment work, before your solving assignment work, I will solve some numerical. Your assignment will be in text. In text question, homework. In text question 3.4, 3.5, 3.5, 3.6 and exercises 3.4 and 3.5, 3.6, 3.4, 3.5, 3.6. You have to solve this problem. Now, I am going to discuss about some numerical. Although in next class we will be focused on the numericals only based on this. So suppose there is a question, calculate reduction potential of half cell reaction at 298 Kelvin, and the reaction is Ag plus aqueous plus electron gives Ag solid. Given E naught Ag plus Ag is equal to plus 0.80 volt. Concentration of Ag plus equals to 0.1. Suppose this is a very simple question. Only single electrode potential you have to measure. Then according to Nernst equation, Ag plus Ag solid equals to E naught Ag plus Ag solid minus 0.0591 divided n log concentration of Ag solid, which will be 1 in divided concentration of Ag plus aqueous. So is equal to 0.80 minus 0.0591 by n, here n is equal to 1 log this concentration of Ag solid is equal to 1, so 1 divided by 0.1. So naturally it will be 0.80 minus 0.0591 log 10. You already know log 10 is equal to 1. Therefore, Ag plus Ag solid is equal to 0.80 minus 0.0591. So that's value, that gives the value 0.741. So this is one example only, and in next class already all students are required to solve these problems, and in next class we will only discuss about the numericals based on Nernst equation, Casey, delta G naught and all. Thank you.